Together with my colleagues and students from wireless at Virginia Tech, we work on a variety of problems related to wireless communications and networks. My particular area of interest over the past decade or so has been mathematical modeling of large-scale wireless systems, where what we are trying to do is to come up with realistic mathematical models that will allow you to efficiently model, design, and optimize these networks. I decided to study engineering because of my interest in mathematics and my innate curiosity about how things work. I was very fortunate to be admitted to the Electronics and Communications Engineering Department of the Indian Institute of Technology, Guwahati. Within the first couple of years, we were introduced to basic electronics and circuits courses. So it just opened up, a whole world of possibilities. What you could do with circuits, what you could do with electronics. Together with a friend from biomedical engineering, we started thinking of doing something new. And at that time, we didn't know what doing something new really means. And we started thinking of, is there a problem that we can solve using what we have learned in the lectures? And we narrowed down to a problem which is sleep apnea. It is a sleep disorder. And we actually made a new circuit to detect sleep apnea. We patented that. And we were even invited to the headquarters of Agilent Technologies to showcase our innovation. And then as I entered my junior year, I was introduced to, of course, more courses. And one of the topics that we covered was wireless communications. And I immediately enjoyed thinking about wireless systems. And there was this urge of learning more about them. I started doing projects. I did one internship on this topic in Italy, and that is what provided initial inspiration to do graduate studies on this topic. And I landed in Virginia Tech to do my master's on this topic. And I specialized in wireless communications. And after finishing my master's, I went to the University of Texas at Austin, which is where I added the mathematical modeling piece to my research interests. So that is where I started working on this mathematical modeling of networks. And I have been working on different variants of this topic ever since. I think wireless communications is and will remain a very important topic for many years to come. I see two main reasons for that. First is that there are just some very important problems that are still unsolved within wireless communications. Although we have provided, global connectivity to a large extent, there are still these remote areas or sparsely populated areas where we do not have adequate wireless coverage. So those type of problems with very high potential societal impact are still largely open. Secondly, if you think about it, wireless communications is also one of the key enabling technologies behind many of the emerging applications. If you think about autonomous driving, automation in general, robotics, wireless communications plays a very important part in these applications, and hence I don't see interest in wireless communications going down anytime soon.